Abhiyanta Siksha is launched with a motto to impart an experiential understanding of technical education. The course outcomes are: equips junior engineers to solve real-time industry problems, prepares graduates for competitive exams, supports engineering students in their graduation studies, benefits diploma and high school students in engineering sciences. Problems are explained, solved, and supplemented with hands-on practice for students. Welcome to the online course Abhiyanta Siksha. The topic that we are covering in this course is engineering mechanics with subtopic friction. Let's start with the definition of friction. Friction is defined as the contact resistance exerted by one body upon a second body when the second body moves or tends to move past the first body. In other words, friction is a retarding force always acting opposite to the motion or tendency to move. Let's understand this phenomenon of friction from these diagrams. Let this be a ground surface and this be a block resting on the ground surface. When the block is pulled with certain amount of force in right direction, frictional resistance force occurs at the contact surface between the block and the ground. The red color surface which is occurring between the block and the ground is said to be frictional surface. This resistance force is represented in opposite direction to the pulling force. Let's understand this through the schematic sketch. If this is the block of weight W, the weight vector is always represented towards the gravity direction and perpendicular to the ground surface. Now, N is the normal reaction occurred by the ground onto the body, and this vector is opposite to the weight W. Now, if P is the pulling force that is exerted on the body, then F is the frictional resistance force that acts opposite to the pulling force P. Now, let R be the resultant vector of N and F, which is subjected at an angle of phi. Let's get into the details of these friction parameters in the next slides. Is friction boon or bane? Let's understand as a bane. In certain machines, the goal is to minimize the retarding effect of friction forces. That means here the friction that occurs should be reduced to have maximum efficiency of the machines. So, the bearings of all types, you can see these ball bearings where the friction occurs on the ball surface, which are held between the inner race and the outer race of the bearing. If the friction is not reduced, then wear and tear of bearings occurs faster. Hence, a lubrication is used in order to reduce the friction. The effort is to minimize the frictional forces. Next example is power screws. The power screw rolls inside the nut and the frictional forces occur in between the nut and the screw. So, it is necessary to minimize these frictional forces to get maximum efficiency of the screws. Another example is the frictional force that exists between the gear teeth. The teeth rolls and slides one over the other, and friction does happen while driving. It is necessary to minimize these frictional forces to maximize the efficiency of the system. Similarly, the fluid friction occurs inside the pipeline, and the fluid friction occurs on the outer surface of the aircraft, which can increase the drag effect on the flights. So, these are some of the examples for friction as a bane. Let's look at friction as a boon. In certain machines, the goal is to maximize the retarding effect of the friction forces. This is an example of belt and pulley. In this particular system, friction in fact is the driving force for the belt to roll on the pulley. So, it is important that friction exists and is maximized to get a better efficiency. Then comes your wedges. Basically, wedges are used to lift the bodies. And here the friction again is a driving force for the function of these wedges. Hence, the frictional force has to be maximized for the better efficiency of the machine. A human being walking on the road requires friction. You just can't imagine to walk on a road or run on a road without friction between the shoes and the road. Similarly, a tire of the car rolls on the road with the help of friction. So, in certain cases, friction is a boon for the system. Now, let's look at the types of friction. They are classified as dry friction and fluid friction. Dry friction develops when the unlubricated surface of two solids are in contact under a condition of sliding or tendency to slide. This type of friction is also known as Coulomb friction. The fluid friction is developed when adjacent layers in a fluid are moving at different velocities. Let's understand the mechanism of friction. Friction exists primarily because of the roughness of the contact surface. Let's look at the contact surface of the body and the ground. No body is perfectly smooth. We can notice the roughness underneath the body, which are closely seen as peaks and troughs. Similarly, there are certain peaks and troughs on the ground surface. Now, when the body is being pulled with force P, there is a chance of these peaks of the body getting interlocked with the troughs of the contact surface. So, due to this, the body develops certain resistance for the motion, and that resistance force is called as a frictional force, which acts in the direction opposite to the main pulling force. So frictional force F has the remarkable property of adjusting itself in magnitude equal to the applied force P till the limiting equilibrium condition occurs. So I am just trying to show you the contact points as the resultant reactions by the ground on the body as R1, R2 and R3. Let's illustrate the mechanism of friction using a graph. Let applied force is placed on x-axis and frictional force is placed on y-axis. When the body is subjected to applied force, there will be an equal and opposite retarding force on the body, which is known as frictional force. The applied force and the frictional force are proportional to each other up to a certain limit. Once the force crosses this limiting point, then the body just starts its motion. That's called impending motion. With a very little increase of applied force, the body is subjected to be under motion. So, when the body is under static condition, that is no motion, the friction that occurred at the contact surface is said to be static friction. When the body just starts its motion, it's called limiting friction, which is maximum frictional resistance. Once the body is under motion, it's known as kinetic friction. So we have three different types of frictions. The static friction, where the body is under rest; limiting friction, which is the maximum friction when the body just starts its motion; and the kinetic friction when the body is under motion. Let's understand the types of dry friction. Static friction. It occurs when F is less than F max. That is, the body is in static equilibrium condition, which means body is purely at rest. The limiting friction occurs when F is equal to F max. That is, the body is in limiting equilibrium condition, which means impending motion, and hence F is equal to F max is equal to mu s into n is the valid equation, where mu s is coefficient of static friction. The kinetic friction occurs when F is greater than F max. That is, the body is in motion, which means F is equal to Fk is equal to mu k into n, where mu k stands for kinetic friction. The condition is impossible since the surfaces cannot support more force than the maximum frictional force. Therefore, the assumption of equilibrium is invalid and the motion occurs. The kinetic friction is less than limiting friction is less than static friction. Laws of friction. The frictional force is always tangential to the contact surface and acts in the direction opposite to that in which the body tends to move. The magnitude of frictional force is self-adjusting to the applied force till the limiting frictional force is reached, and at the limiting frictional force, the body will have the impending motion. Limiting frictional force Fmax is directly proportional to the normal reaction. For a body in motion, kinetic frictional force Fk developed is less than that of frictional force Fmax, and the relation Fk is equal to mu k into n is applicable. Frictional force depends upon the roughness of the surface and the material in contact. Frictional force is independent of the area of contact between the two surfaces. Frictional force is independent of the speed of the body. Coefficient of static friction μs is always greater than the coefficient of kinetic friction mu k, where mu k may be 25% smaller than μs in general. And μs and mu k are dimensionless parameters. Coming to the values of coefficient of friction, as we have already studied under the laws of friction, the coefficient of friction depends upon the material contact surfaces. The metal on metal is 0.15 to 0.60. The metal on wood is 0.2 to 0.6. The metal on stone is 0.3 to 0.7. Metal on leather is 0.3 to 0.6. Metal on wood is 0.25 to 0.5. Wood on leather 0.25 to 0.5. Stone on stone 0.4 to 0.7. Earth on earth 0.2 to 1. Rubber on concrete 0.6 to 0.9.